Here is extra credit problem number 2. Sorry I didn't give you very much room on here. I write really big. I'm probably going to run out of room, but let's give it a go. So notice I have two logs that have the same base as we reviewed in problem 1 of part 1. If you are adding together two logs with the same base, you can multiply the values together. So I can simplify this as log base 2 of 2 sine x times cosine x. All right, now this is why I gave you all these formulas. Notice this part right here looks like this one right here. So I can substitute sine of 2 theta in for this guy right here. So I can rewrite this as log base 2 of sine of, I'm going to use x because I don't have a theta here yet. Okay, so I'm going to say that sine of 2x because we're using x, not theta. Okay, so we just used these formulas, which we haven't derived, we haven't proven them, and hopefully if we have time in class, we will prove them. Otherwise, I'll put some videos up of how to prove this. But IB just expects us to fake it and just use some formulas we don't know where they came from. I don't like that myself. I like to prove things before I use them. So we'll try and get around to doing a proof of that eventually. But right now, we're going to fake it. All right? We're going to pretend we know what the heck, where this came from. We're going to just use it. So I'm substituting in something for 2 sine theta, cosine theta. Okay, so, oops, what did I just do? Oh yeah, so next, what do I need to do is I need to rewrite this in exponential form. Okay, so this is all equal to, I forgot to write what it was equal to. Sorry, I'm not paying attention to what I'm doing. This is equal to -1. I forgot to copy that down. I put the equal sign on the wrong side. That's equal to -1. All right, so now I'm going to change it to exponential form. So, because I'm stuck. Whenever I get stuck, I go, what should I do? Change the form. 2 to the -1 is equal to the value sine of 2x. Okay, now this is starting to look more reasonable. Sine -1, I can write that. That means I move the 2 to the bottom of a fraction. So that's, I'm dividing by 2 1 times. I'm dividing by 2 1 times. Oh, this is looking more and more promising. Sine of some angle is equal to 1/2. Sine of some angle is equal to 1/2. Hey, we can do that on the unit circle. That is part of our unit circle. So if I make my little unit circle sketch, where do I have sine values that equal 1/2? Okay, so I have that on my 30, 60, 90 triangle. So if I have my unit circle already sketched out, I know that when I do my 30, 60, 90s, it goes square root of 3 over 2 up 1/2. Okay, this point right here is square root of 3 over 2, and the y value is 1/2. And sine is the y value. Remember, it goes cosine, sine. And the easy way to remember that is in alphabetical order. X, y, cosine, sine. Alphabetical order. All right, so my sine has a value of 1/2. Where else do I have a value of 1/2? Over here, reflected across the y-axis. This point also has a sine value. This is negative square root of 3 over 2 and 1/2. So this also, this angle right here also has a sine value of 1/2. Okay, so that means that this guy right here, 2x, has to equal, what are these angles? So you can do it in degrees or radians. Does it say? Does it care? It doesn't even care. It doesn't even say. You could use degrees or radians. So I can say 2x, this puppy right here, what does that have to equal? How many degrees is this? Let's go ahead and do degrees because people are generally better with degrees, or I can do it both ways. Okay, so anyway, that would be 30 degrees. Or over here, let's see, this is 30, 60, 90, 120, 150, 180. So that's 150. So, or 2x is equal to 150. I should put my little degrees. Okay, if you did it in radians, of course, you would have 2x is equal to pi over 6, because 1, 2, 3, 4, 5, 6. There's 6 pieces here, 1, 2, 3, 4, 5, 6. So the first one would be pi over 6. Or 2x is equal to 1, 2, 3, 4, 5. 5 pi over 6. And now we just need to solve to get x by itself. So if we solve each of these to get x by itself, divide both sides by 2, I get x is equal to 15 degrees. And here, x is equal to 75 degrees, or if I was doing it in radians, I get x is equal to pi over 12, or x is equal to 5 pi over 12, because I'm dividing, the 2 comes to the bottom. The 2 comes to the bottom. So there are my answers. Okay, notice the domain. It says that x has to be between 0 and pi. How did we do? Pi is the same as 180 degrees. So are we good? Yes, we are good. Our x's are well within range. Okay, one thing that you do need to be careful on this is if you change, see how we had x as being times by 2 in here? We really need to also double the domain, because when we divide by 2, that's when we bring the domain back down to this. So really, when you're solving this, you should actually, when you're looking for what angles have a sign of 1/2, you really should be looking all the way around the circle, because you really should be multiplying your domain, multiply it by 2. So you really should be looking to go all the way around the circle in this case. But if we do go all the way around the circle, we're not going to find any more signs that are equal to 1/2, because this one is negative 1/2 and this one is also negative 1/2. So these are the answers. Okay, so the two answers, here they are in radians, pi over 12 and 5 pi over 12, or in degrees, x is equal to 15 and 75 degrees. And there it is.